Now this latent state is so mysterious and so comprehensive, it basically has all of the information about everything in the brain that we give it a star. That's why we say X star, because we can't directly see it. But there are some things that we can indirectly observe that are related to this X star. So for instance, you might say, well, this guy, his knees are weak and his arms feel heavy and he's kind of sweaty. So it makes you think, all right, this X star thing is sort of the fundamental, full state of the brain. But what we're interested in for psychopathology are kind of these functions on that brain state. So in this case, this test subject I has on his mind anxiety. There's this measure of anxiety, this sort of ground truth measure that we also can't see directly. This is just happening in his brain. And this F function is mysterious. Maybe the output is a scalar, maybe the output is a vector, maybe it's something else that's mysterious. But this is really what we're trying to get at, the idea of all of these internal latent structures inside of this person that we can't directly see. But the sort of goal of a lot of psychology and basically characterizing psychopathologies is about trying to get a grip on understanding these things. And just for diversity, we also have test subject J. And on this person's mind is psychosis, which is hard to understand if you're experiencing it, and also just hard to understand in general. And so these two participants are basically our characters here. I can draw all of the knees weak and stuff for the other person because there's not a nice Eminem song for that. But the test subject I goes to the psychologist. In this case, it's Carl Jung over here. And after talking with Mr. Jung, Dr. Jung, basically, Carl Jung comes up with this estimate, X hat, of the patient's latent state, right? So we try to get an understanding of really the underlying variables that are sort of relevant. It's an estimator though, and so it's not really perfect at doing this, but the hope is that it's good enough that when Carl Jung then tries to estimate, okay, what is the estimated level of anxiety, this F hat of X hat, so they're both estimators, and they're trying to get at this internal thing. The goal is that Carl Jung is enlightened and is able to basically produce this estimate well, because he both understands how this latent structure of human psychology works, and also this specific axis or readout of anxiety. So the weird thing about human psychologists and the history of psychology is that they say some crazy stuff. In addition to just saying, oh, here's your latent state, you have 0.5 anxiety or something. Carl Jung actually said this about a patient that he was treating for psychosis, where he said, whenever she showed signs of going off into a psychotic episode, I let myself sink back into the unconscious, and it would give me the idea of some obscene joke. It had to be terribly vulgar, but when I merrily told it, she would always laugh and become normal again. I could bring her back from the underworld in that way. It was absolutely saving. Now, whether or not you believe that this is actually the optimal solution to psychosis in general, it seems like having a really strong grasp of these latent variables, a really strong grasp of the nature of the person, lets you sort of go beyond just saying, all right, we're going to estimate this scalar level of anxiety. Carl Jung can come up with these crazy things. Psychologists can come up with these maybe creative solutions where it's like, okay, I know you very well. I understand your latent state very well. And I can tell, oh, you should do this, or I should tell you this vulgar joke. And I guess sometimes it ends up working out for them. So when we're thinking about this mathematically with these functions and these latent variables, it's kind of challenging to see, okay, how do we sort of progress the field? How do we move on from, preferably we'd be able to systematize or make this more rigorous, right? But we also want to maintain that ability to kind of creatively ascertain this latent state of the patient and also come up with maybe novel solutions and basically get a deeper understanding. But if we have to rely on this sort of semi-spiritual individual person, Carl Jung, who's very good at this, I guess, maybe there are other really gifted psychologists and psychiatrists in the world, that is a little bit tough because the way that this guy learned how to do this was through a whole lot of philosophy, alchemy, I think, as well. It's like a whole lot of things went into this, and it's also unclear how you really test, if there's another Carl Jung being that has a different way of doing this, then how do you compare them, right? It's very challenging mathematically. So the next part of the story, this participant I is like, okay, this Carl Jung guy is super weird. I'm just going to go for the modern sort of questionnaire approach to figuring out my level of anxiety. So the I of test subject, I framed him as an input-output system here. As the input is an unfilled questionnaire about anxiety, and the output is a filled-in questionnaire about anxiety. And the whole idea behind these psychological questionnaires is that as a function of the filled-in questionnaire values, so you bubble in these, oh, I very much agree that I feel sweaty all the time. I very much agree that my knees are weak, or something like that. Some function of those questionnaire answers will hopefully estimate this underlying anxiety state, or whatever the psychopathology might be. That's kind of the strategy of these questionnaires. And so the question for you guys is, who would win? Would it be Carl Jung with his mysterious, deep understanding of human psychology, this borderline spiritual sort of way of doing things? Or would it be this questionnaire? Anybody want to take a bet? Sorry? Carl? Nice. So, Pietro, do you think that means that this inequality will face in that direction or that direction? The right side would be smaller because this error between Carl Jung's estimate, F hat of this mysterious X hat, his estimate, is somehow closer to the underlying thing. And I would probably agree, right? I think that that's reasonable. But this is a trick question, because you already saw the title of the talk. We are going to use LLMs to do it. But before we do that, the reason the History Channel guy is here is because one of the things from your instructions for the talk was to try to recognize when AI is being used well, when it's not being used well. And I think it's very easy to kind of jump ahead of ourselves, where it's like, oh, let's just use the AI, just upload everything to ChatGPT, just do this. But it would be really nice if we could have maybe a more principled approach, maybe have some guarantees on that. So let's get back to this question, which is a little bit more well-framed between these questionnaires and this mysterious psychology individual or psychologist individual. So, next question for you guys. We're on a roll with the first one. Which way will this inequality face? So this is asking, is the mutual information between this questionnaire response, that's the Y value, and the underlying latent state, the mysterious thing we're trying to get at, does that share more information, basically, than the psychologist's estimated state of the person and the actual estimated state? Any takers? Which way? Yeah, what's up? I would agree, because the psychologist is talking to the person, they can kind of navigate around what to talk about, and they're not really fixed to these bubbled in, questionnaire answers. Now, here's the challenging question. What if it was an infinitely long questionnaire that had infinitely many hyper-diverse questions? Now what? Which one's gonna be better? It's got a chance. There are a few problems though. For one, it's all self-report, so it's relying on the person to make these accurate, basically estimates of their, answers to all these questions, which, if you have anxiety and then you're anxious about taking the anxiety test, well, that's kind of going to mess up your measurement process there. And so there's sort of this weird self-referential thing, you're looking at really what the person thinks of it and how the person interprets the question. And most of all, it's a real pain in the ass to fill in an infinitely long questionnaire. And so that is sort of one of the motivations though. If you have this infinitely long questionnaire, intuitively, we agree, at least Pietro and I agree, that it has a chance. If it's really long, if it's really comprehensive, then maybe. We still have this sort of self-referential thing, the self-report issues. So when we move on to the language model, now here's the claim I'm going to make, and this is kind of maybe a more stronger claim about this idea that it has a chance if there are infinitely many questions. So let's say that our participant over here, just a generic participant with latent state X star, this guy gives some information to a system. This information, imagine it's really comprehensive information. Maybe it's everything they've ever done on the internet ever. Or it's everything they've ever said to their psychologist in every conversation. So this rich data, Y, that hopefully contains this information about X star that we're interested in, or at least a good amount of it. It's fed into this optimal multi-classifier, which basically takes the test for the person. And so this optimal multi-classifier, we'll get more into the specifics of it. Maybe it's an LLM, we'll see. But it assigns probabilities to the answers to these questionnaires, given this big information, the information dump of this person, which we denote Y. So it's saying, okay, here's the probability of the answers to question 1 given this thing, question 2, question 3, for this mega questionnaire, which is getting closer to infinitely long, but probably not actually infinitely long yet. Haven't figured that out. But in any case, it produces these accurate predictions of many of these measurement values, these estimated sort of functions of the true latent state, where every answer to every question, theoretically, if the latent state is truly a state, it contains all the information about the person, every answer to every question is basically one of these estimators, this F hat, in this case of Y, which is the big transcript thing. So the claim is that if you have an optimal multitask classifier, it actually ends up needing to disentangle the latents under certain terms and conditions, but basically that was the topic of some work that I did with Pantelis. So he was doing sort of computational experiments with this, and we started working together. I was like, I feel like we can prove this. We can prove that if you have this huge number of different tasks that a system needs to do, so these classification boundaries sort of represent the questions we're answering, the things we're estimating with this mysterious LLM back here. If you have some, optimal system that's computing these likelihoods over classifications, and many of them, then you can actually prove, and we won't get into the full proof, but it gets kind of hairy, but it's kind of turns into linear algebra at a certain point. But you can prove that if you have enough of these questions and they're sort of diverse enough, then you're going to basically be able to disentangle this, X star thing, the fundamental, thing you're basically sampling observations off of, these noisy observations that are partial observations of the real latent state of the person, so maybe it's stuff they said. You get these observations, and then you can show that the state of the optimal multi-classifier must contain this latent value, and the nice thing is, there's actually closed form equations for that from this theory. So as much as it's painful to read through that last slide, the benefit we get out of this is that we have some amount of guarantees, at least for our Gaussian noisy or sort of setup, this sort of maybe more of an idealized problem setup. We can make some guarantees, and then we can derive some equations where we say, all right, given that I have all of these optimal multitask classification estimates, I can use these equations to kind of reconstruct this estimator for the X star value. So what this stuff suggests is that if our assumptions from the theory are more or less applicable to the real world of language models or optimal predictors and human behavior, we would expect that if this optimal multi-classifier assigns sort of correct likelihoods to potential answers to all of these questions, then there must be this encoded state. Now the nice thing is that language models are trained to produce these maximum likelihood estimates that we're talking about in the theory. They're not optimal though, so if only there was a way to extend the theory to suboptimal classifiers. Well, as it turns out, it kind of naturally does. So basically, what we initially were testing for this is a synthetic data experiment. I don't have much time left, but we started by saying, okay, let's just use some synthetic prompts about certain members of this population are neurotypical, certain members exhibit autism symptoms, and you have this big autism questionnaire. You feed in this prompt representing the person and the questionnaire, and it assigns these likelihoods. And what we want to see is, okay, let's see what those accurate multi-class estimations are for the answers to the questions, and do some dimensionality reduction on them. So we take these different questions, we take these different prompts that describe neurotypical people versus autistic people versus maybe neurotypical people pretending, and lo and behold, there's this separation in the PCA space, so that's a good preliminary result. And so the final way that we want this to go I'll just show one more thing, is to essentially augment this with a subsystem that proposes these latent factor models. So we put this full digital footprint of the person through a bottleneck, where we basically project it onto some proposed latent factor model. We take that projection, feed it into the multi-classifier, and our goal is to make sure these predictions remain accurate. They're still the same as the original when we didn't filter it through this latent factor model. And we're trying to basically optimize the latent factor to make sure they're accurate, and also minimize this, compressed representation or latent representation. And I believe that's a very good way to maybe try to come up with better, models of how diseases work, psychopathologies work, for instance, subtypes of autism, other stuff like that. And the best part is, our good friend Henry Lane, the top student in CNS 286, well done Henry, has done all of the hard work of actually, trying to build out this big software system that will also automatically refine these latent variable, basically latent variable models. And hopefully you can just throw in a bunch of these big transcripts or data dumps from many different people who are suffering from some psychopathology. All that you have to do is come up with many of these questions that somehow get at this latent factor that you're interested in. And then you just let the machine go burr, GPUs go fast, and just let it chug along, and if Henry's thing works, which I think it will, then you have, I think, a good chance of understanding these psychological latent variables in a way that we've never really been able to understand before, except maybe if you had a psychologist who knew you really well and basically had some similar access to this big data dump of your entire state history, your entire internet history, or everything you've ever said to them. Now we can use language models to get away from having to have a human kind of systematize this and just use them. And it seems like there are some guarantees. So I'd like to say thank you again to all of the collaborators on this. I know that there's not much time left, but one thing I'd like to thank especially is Ralph, who, when I tried to join his class on consciousness late, because I was interested in language models, he said no. But let's start a reading group with you, me, Frederick Aberhart, and Matt Thompson, as well as Tessa and Brenna, who joined. And we met pretty regularly, and it actually ended up turning into this. So I'd just like to say thank you, Ralph, for doing that. And also thank you to Christina Porcello, who's an autism expert at UNC, as well as Lynn Paul, who's a research scientist here at Caltech, who have both taught me a lot about the psychological picture, where I'm kind of coming at this from a machine learning background. So thank you very much. And so
slightly facetious question. How far away are you from making it possible to ingest all Facebook and Twitter and diagnose mental issues of everyone?
Well, the main barrier is IRB approval. Full disclosure, I actually have made some models where we kind of baked in a large amount of information just scraped from the internet, like everything someone's written on Twitter, everything someone's written on their blog. And we have this other paper called prompt baking that lets you do that, seemingly very high efficacy, but it's kind of a story for another time. I probably should not actually test it for psychological latent factors yet, because he also didn't. I need to get the IRB approval. But I think we're pretty close. I think we have a model that does that for a person, but I cannot show it to
you. Great work actually, interesting concept. I'd like to see where this goes. My question is that even for building an optimal multitask classifier, you need to have an understanding of what is the dimensionality of the latent space that you're studying. And to begin with, psychopathology, you cannot actually define the latent space that accurately, so what do you propose?
I think that fundamentally what it comes down to practically is what you expect the entropy or the information content of these things to be, which is basically another way of looking at this dimensionality problem. So the reason that the objective is to minimize this, the absolute value of the y thing, the projected value of the latents, is because we do want the simplest, most concise possible sort of compressed latent set of factors that still produces these accurate classification estimates on all the questions that the psychologists came up with, this mega questionnaire that has a ton of questions relating to the latent factors where you're interested in. So yeah, does that sort of answer your question? We kind of have this goal to minimize this. We're not entirely sure what the lower bound on that minimization might be at the beginning, but we have this constraint that says, okay, we can't make it so small that it stops producing these accurate classifications, and that kind of lets us invoke some of the theory stuff, and yeah, does that answer your question?
I could stop you, because we have many questions for Aman, but unfortunately we are through with the time allocated.
Get your money, man. Life goes on. Let's hope.